Now let's discuss the motion of a simple pendulum. Let's say we have a pendulum whose length is exactly 1 meter and the mass m is attached to the other end of the pendulum and the upper end is fixed to the rigid support of the wall. Our pendulum is at equilibrium position right now. It's not moving, and this position is called resting position, mean position, or equilibrium position. If I am going to displace it from its resting position or equilibrium position, it will start to vibrate to and fro about its mean position. As you can see, let's say in a slow down motion that the object is going to the extreme position. This is the maximum displacement the pendulum can achieve at the right side, and this one is the maximum displacement at left hand side. So these two positions are called extreme position and the central position is called mean position. So the pendulum is vibrating to and fro about its mean position, and its acceleration or the force is acting towards mean position. And how can I say that? Because the weight always act downward. So that's mean the weight of a pendulum is acting vertically downward, but due to the inertia it is not going to stop at this position and it will going to the other side, just because that it is in motion while it's coming from the extreme position. It gets velocity, and due to its velocity is not going to stop at this position, although the restoring force wants this object to be stay at its equilibrium position, but it's not going to do so. So this is the simple harmonic motion for you, and the question usually come in your question paper. Let's going to discuss the question. Prove that the motion of a pendulum is simple harmonic motion. To prove that its motion is simple harmonic motion, first we have to define what is simple pendulum. Simple pendulum consists of a bob of a mass m, as you can show here, suspended to the end of a string whose upper end is fixed. That means it's in hanging position. If a bob is displaced from its equilibrium position, it starts to vibrate about its mean position. So this is the basic definition of a pendulum. Now there is a time to prove that the motion of a simple pendulum is simple harmonic motion. Moving towards the proof, we have to prove this by 12 statement, or you can do this in a single paragraph. Maybe you can write this all in a single paragraph, just because it is easy to remember in points. So I'm just proving this in 12 points. Number one, consider a pendulum of a bob of a mass m at equilibrium position O as shown in a figure. The net force on a bob is 0 and it is in a resting position. As you know, the tension in a string and the weight of object, the weight of mass m, cancelling out each other, and therefore there will be no motion along the string or maybe in any direction. It will be in a state of rest. If we bring the bob to extreme position A, now if we are going to displace it from its equilibrium position and we are taking this to point A, the net force start to act on it directed toward mean position. Now the force will start to act that pulls the object towards mean position. If I am going to release, then what will happen? Definitely, due to the force, elastic restoring force was there in the mass spinning system. The weight is a force acting towards mean position in mass in simple pendulum. So it will pulls the object towards its mean position. There is no net force acting along the string, as the tension in a string cancel the component of a weight mg cos theta. Now if we are talking about weight, the weight is acting directly downward, vertically downward, but as we know that it can't move downward because of the tension in a string. This tension in a string, the string will not allow the mass m to go downward directly. Therefore we are resolving weight into its perpendicular components. We are resolving the weight into its two components. So the weight has a two parts. Let's say it is applying force with the two hand. Let's suppose it's first hand and the second hand. If we are talking about the component of a weight mg cos theta that we have discussed in 9 class, that we can resolve any vector into its perpendicular component. This is the year 9 class topic. So if I am going to resolve weight into its perpendicular component, then the component mg cos theta will be cancelled by tension in a string. That means the tension will not allow the object to go in this direction, because the tension is cancelling out the mg cos theta component, not the whole weight, not the whole motion of the object. It's only cancelling out the tension is only cancelling out the force acting along the string. Now the component of a weight mg sin theta is directed toward mean position. The motion of a pendulum is due to the component mg sin theta that is acting towards mean position. This component is forcing the mass of the bob to comes to its equilibrium position, and that is why, and there we can say that this is the restoring force that is required in any of the simple harmonic motion and satisfying the second condition, that it is directed toward mean position. Now due to this force, what will happen? The bob start to move towards mean position O. It will definitely go to the position O. But is it going to stop there? No. At O, the bob got maximum velocity and does not stop due to inertia and move towards the other extreme position B. We know very well that the object in a state of rest or the object in a state of motion will continue in its state unless acted upon by an unbalanced force. So we can say that when the bob reaches to point O, it has higher velocity, maximum velocity, due to which it's not going to stop at this position O, and it will moving to the other side, to the other extreme position B. While it is moving to the other side, the velocity of the bob decreases due to restoring force again, because the weight does not wants this object to go to this side. The weights always want this object to be at equilibrium position. So that again the force start to act on object, and then and what will happen? It will decrease the velocity of the bob. Now as the velocity is decreasing at extreme position B, at extreme position B, its velocity will become 0, and then again the restoring force acts on it, which is directed toward mean position, hence it move to position O. Now it will be coming again back to the position O, and what will happen next? We know very well that in this way the bob continues to move to and fro about its mean position. Then it will not stop at position O, then it will goes to the position B, to the position A due to the inertia, we say, having maximum velocity at point O, and then when it reaches to point A, and then again restoring force and so on. Now the acceleration of a bob during the motion is directed toward mean position. We were watching that every time the object leaving the mean position, the force or the acceleration is pushing or pulling the object to come back to its mean position or equilibrium position. That means the acceleration of the force is acting directly toward mean position, which proves that the motion of a bob of a pendulum is simple harmonic motion. So hence the motion of a bob of a pendulum is simple harmonic motion. So if we are going to prove this by 12 statement, that's it. We can prove this mathematically, but it's not in your matric class level. We are going to prove this mathematically in first year level. Now take out your register and copy down your second question starting from the proof, and you need to draw a diagram first.